Okay, today I'm going to talk to you about series circuits. So to do this, I'm just going to draw a simple circuit right here. So here is an ammeter. Here is one filament lamp. Here is another filament lamp. And here is another ammeter. So that's what I'm going to do to begin with. So a series circuit, the way I remember it, is S is for series, S is for single, because there's just a single route for the electrons to flow around. There's just a single loop. In a parallel circuit, there's more than one way for the electrons to flow around, but in a series circuit, just one way for the electrons to flow around. Now, this means a huge disadvantage of a series circuit is if I have two filament lamps, and let's say this one breaks, that breaks the whole circuit. That means the electrons can't flow all the way around the circuit, and as a result, that bulb will also go out as well. So that's a big problem with the series circuit. Another issue is, the more bulbs we put in, the dimmer each bulb will appear. And we'll see why in just a minute. So, first of all, let's have a look at these ammeters. So, an ammeter, if you remember, measures the flow of electrons, the current, the flow of charge around the circuit. So, anywhere in a series circuit, let's say if this ammeter here read 10 amps, then I know for a fact that this ammeter here, A2, would also read 10 amps because the current is the same everywhere in a series circuit. We've just got one way for the electrons to flow, one way for the charge to flow. So as a result, it's going to be the same everywhere. Where it gets slightly different is when we start looking at potential difference. So let's imagine this cell here has a potential difference of 10 volts. If I put in this voltmeter here, first of all, if I put a voltmeter in, even though voltmeters are connected in parallel, this circuit is still called a series circuit because the voltmeter is just there to read the potential difference. So if I've got two voltmeters in here, one around that filament lamp and one around that filament lamp, what is the potential difference going to be for each? So in order to do this, it's kind of a good idea to turn this on the side. So what we're imagining here is as the charge goes through our cell, the cell is giving it the energy. It's as if it's lifting it up and giving it energy. All of that energy needs to be transferred across these two components. And that energy is going to be shared equally across all of them. So if we've got a 10 volt cell, all 10 volts need to be evenly distributed across V1 and V2, across the first component and the second component. So if I've got a 10 volt cell, V1 is going to read 5 volts and V2 is also going to read 5 volts. This is the reason why the more bulbs you put in, the dimmer they will be, because less energy will be transferred across each component. So that is how current and potential difference works in a series circuit. I'm just going to do a really simple series circuit just underneath, just to show how resistance works, because resistance is probably the easiest out of everything and how it works. So remember, resistance is what restricts the current, restricts the flow of charge around the circuit. So if I've got this resistor here, let's say that's 3 ohms, and I've got this resistor here, which is 2 ohms, in order to find the total resistance in the circuit, all you need to do is 2 plus 3, which is 5 ohms. So to find the resistance in a series circuit, all you need to do is add the resistance together to find your total. So just to summarise, in a series circuit, the current is the same everywhere. The potential difference is shared across each component, and it will be shared evenly as long as they have the same resistance. And finally, resistance is calculated just by adding together the resistance from the different resistors. And that is the outline of a series circuit. Thank you.